In this video, you will learn about tension forces, how to draw the free body diagram, and eventually solve word problems such as this one. Subscribe for contents like this and comment the topic you want to study next. Let's start. When an object is attached to a rope or a string, there will be a tension force in the rope, and that force is directed away from the body. Every time you see a situation with a rope or a string attached to a body, the direction has to be away from the body, in this case to the right. If you have this, it's pointing to the body. That's not correct. It has to be to the right in this case. For multiple objects attached to the same string, you will show the tension forces away from the body for each object, and they will have the same value. For example, if this is 10 newtons, this is 10 newtons as well, because the same rope will experience the same tension throughout its length. To draw the free body diagram, let's take this example. If you have tension T right here, and then force mg acting downward if it's on a surface, normal force acting upward. If it's moving to the right, then there will be a friction force like this. And then you will start writing the components of forces in x and y direction to solve your word problem. Let's start with this one. Notice the word tension singular. It's because they are both connected to the same string, so the tension force will be the same. Here it's away from the body, so to the right. Here this tension is away from the body, so pointed upward. And acceleration singular again. It's because they are moving together, so they will have the same velocity and same acceleration. We know that mu is 0.2, the coefficient of kinetic friction. Now let's draw the free body diagram of the first. We have 6 kg, tension acting to the right, it's on a surface, mg downward, force of normal up, and force of friction would be to the left. I am assuming that the box moves to the right, so the friction would be to the left. Now let's write the force equation. But before that, force of friction can be calculated. It's mu times of Fn. And force of normal is same as mg, which is 6 times 9.8, 58.8 Newton. So using this Fn here, force of friction is 0.2 times 58.8, 11.76 Newton force of friction. And now, since it's going to the right, let's write the forces in the x direction. Sum of forces in the x direction would be tension to the right minus force of friction to the left. And those are all the forces. Net force is equal to mass times acceleration. Mass is 6 times acceleration a. T minus force of friction is 11.76. That would be 6a. Now we have two unknowns, t and a. So we need at least two equations. To get the second one, let's draw the free body diagram of the second object. This is 13 kg. mg is acting down. Tension is acting upward. Notice I'm using the same T and T because they both have the same tension. Since it's going downward, mg would be a bigger force compared to T. That's why it's going down. So you do bigger force minus smaller force, that's the net force, equals mass times acceleration. Mass is 13, acceleration is a. mg would be 13 times 9.8 minus t equals 13a. 127.4 minus t equals 13a. Now from the first equation I can isolate for t, it is 6a plus 11.76. From the second equation, 127.4 minus 13a is equal to t. Now this is equation 1, this is equation 2. They both represent tension. So you can say that they are equal in value. 6a plus 11.76 would be equal to 127.4 minus 13a. 6a plus 13a equals 127.4 minus 11.76. 19a equals 115.64. Divide both sides by 19. You get a as 6.08 meters per second square. Now that we have acceleration, you can plug it either in equation 2 or in equation 1 to get the value of tension. When you do that, you will get tension as 48.3 newtons. If you understand this solution, try the next problem by yourself. Here, there is no friction, so it should be even easier for you. Write your answers in the comment below.